belongs to A intersection B. അപ്പോൾ x will belong to A, x will belong to B. A intersection B ഉണ്ടാവും and x will belong to A union B also. അപ്പോൾ chi of A intersection B, chi of A, chi of B and chi of A union B, all of this are equal to 1. അപ്പോൾ നമ്മുടെ equationsൽ നമുക്ക് വേണ്ട values ഇതെല്ലാം ആണ്. അപ്പോൾ എല്ലാം 1 ആണ്. Now let us verify whether the equation hold or not. Chi of A intersection B will be equal to 1. That will be equal to chi of A into chi of B. അതുപോലെ chi of A union B 1 ആണ്. And this will be 1 plus 1 minus 1. Again we are going to get 1. So therefore both the equations are verified when x belongs to A intersection B. Now the last case is when x does not belong to A union B. If x does not belong to A union B means if x will not belong to A, x will not belong to B, x will not belong to A union B, otherwise x will not belong to A intersection B. So what happens is in this case all the chi values are equal to 0. So chi of A, chi B, chi of A union B, chi of A intersection B, all will be equal to 0. So നമ്മൾ equations verify ചെയ്യാൻ നേരം എല്ലാ equationന്റെയും രണ്ട് equationന്റെയും left side ഉം right side ഉം രണ്ടും 0 ആയിരിക്കും. So in this case also the equation is verified. So whenever x belongs to inside A union B, A B, A intersection B and A minus B or B minus A, അപ്പോൾ ആ കേസിലെല്ലാം equations verified ആണ്. അതുപോലെ തന്നെ if x does not belong to A union B, in that case also equation is verified. So those are the only possible choices for x. X ന് 4 cases മാത്രമേ എടുക്കാൻ പറ്റുള്ളൂ. So in all these cases for any set A and B, this equation always holds. So therefore we can conclude that chi A union B is equal to chi A plus chi B minus chi A into chi B, and chi of A intersection B is equal to chi A into chi B. Now the next part of the problem was we need to show that chi of A complement is equal to 1 minus chi of A. So take an x belongs to A. So if x belongs to A, then x does not belong to A complement. So chi A of x will be equal to 1 and chi A complement of x will be 0. So you will get chi A complement equal to 1 minus chi A of x. So this is the case where ഇപ്പോൾ നമുക്ക് ഒരു സെറ്റ് A എന്ന് പറയുന്ന ഒരു സെറ്റ് ഉണ്ട്. So you have a set A. So രണ്ട് കേസസേ ഉള്ളൂ. ഒന്നെങ്കിൽ x എയുടെ അകത്താവാം അല്ലെങ്കിൽ x എയുടെ പുറത്താവാം. അപ്പോൾ ആദ്യം നമ്മൾ എടുത്ത x belongs to A ആണ്. x belongs to A ആവുമ്പോൾ the equation holds. Now if x belongs to A complement, so this is A complement set ആണ്. So if x belongs to A complement, then in that case x does not belong to A. If x belongs to A complement ആവുമ്പോൾ chi A complement will be equal to 1, chi A will be equal to 0. So again you will get chi A complement equal to 1 minus chi A. So again the equation is verified. So in both the cases, so if x belongs to A or x belongs to A complement, in that case chi A complement will be equal to 1 minus chi A. So therefore that will be the characteristic function corresponding to A complement. Now let us look at another problem. So the next problem is to prove that the sum and product of two simple functions are simple. So let us consider two simple functions. So we will show that the sum and product of two simple functions is simple. So function simple ആവുന്ന function measurable ആയിരിക്കണം. Function must assume only finite number of values. So we will show that phi plus psi. We will take two simple functions phi and psi. Phi plus psi and phi into psi are again simple. ഇനി നമ്മൾ മെഷറബിൾ ഫംഗ്ഷന്റെ പ്രോപ്പർട്ടീസ് കണ്ടപ്പോൾ നമ്മൾ കണ്ടു എഫും ജിയും മെഷറബിൾ ആണെങ്കിൽ എഫ് പ്ലസ് ജി മെഷറബിൾ ആയിരിക്കും. അതുപോലെ എഫും ജിയും മെഷറബിൾ ആണെങ്കിൽ എഫ് ജി പ്രോഡക്റ്റ് വിൽ ബി മെഷറബിൾ. നമ്മൾ ഓൾജിബ്ര മെഷറബിൾ സെറ്റ്സ് കണ്ടപ്പോൾ നമ്മളത് കണ്ടതാണ്. So here phi and psi രണ്ടും measurable simple ആണ്. Simple ആണെങ്കിൽ measurable ആയിരിക്കും, finite ആയിരിക്കും. So measurable ആയതുകൊണ്ട് again phi plus psi is measurable and phi into psi is measurable. Now to complete the proof that the sum and product is simple, we need to show that they assume only finite number of values. Simple ആണെങ്കിൽ finite number of values എടുക്കും. Since phi and psi take only finite values, അതിന്റെ sum എടുക്കുമ്പോഴും നമുക്ക് finite values add ചെയ്യുമ്പോൾ വീണ്ടും നമുക്ക് finite number of values കിട്ടുള്ളൂ. അതുപോലെ finite numbers in the product എടുക്കുമ്പോൾ, so take all the possible products of phi and psi values, again you will get only finite set of values. So they are measurable and they are again finite. So that completes the proof. So phi യും psi യും measurable ആണ്, they take only finite number of values. So phi plus psi and phi into psi are measurable since sum and product of measurable function is measurable. So they'll take only finite number of values. So therefore we can conclude that they are simple functions. Okay. Now nammal simple function the characterization kandu using phi and psi. So for phi plus psi and phi into psi, you can represent using the canonical form. So if you have the simple functions phi and psi, phi, suppose take the values, distinct values a1, a2, an on disjoint measurable sets capital A1, A2, an. അതുപോലെ psi യുടെ values b1, b2, bm എടുക്കുക on the sets capital B1, B2, bm. So phi plus psi will take the value ai plus bj on ai intersection bj, where I varies from 1 to n and j varies from 1 to m. So phi using canonization, phi can be written as summation I equal to 1 ai into chi of ai, as well as I in j equal to 1 to m bi into chi of bj. In phi plus psi will take the value ai plus bj on ai intersection bj. So we can write phi plus I as sum over I, sum over j, ai plus bj in the interval ai intersection bj. So phi of ai intersection bj വരും. അതുപോലെ phi psi will assume the value ai bj on ai intersection bj. So phi psi, the product of simple functions can be written as summation over I, summation over j, ai bj into chi of ai intersection bj. So this is how we represent the sum and product function in terms of characteristic function. പിന്നെ അതുപോലെ തന്നെ if you have a simple function, then the scalar multiple of a simple function is again simple. So c constant ആണെങ്കിൽ c5 എടുക്കുമ്പോൾ it will take the value ca1, ca2, can. And a1, a2, an corresponding ആയിട്ടുള്ള sets capital A1, A2, an ആണ്. അങ്ങനെയാണെങ്കിൽ it can be represented in the canonical form. So in the set a1, c into phi will take the value ca1, a2 ൽ ca2 ആയിരിക്കും, an can ആയിരിക്കും. So it can be represented as c5 equal to summation I equal to 1 to n cai chi of ai. And again one more note, this is on linear combination. So നമ്മൾ ഇപ്പോൾ sum നമുക്ക് canonical ഫോമിൽ എഴുതാമെന്ന് കണ്ടു. അതുപോലെ scalar multiple canonical ഫോമിൽ എഴുതാം. So combining both, so if c1 and c2 are constants and phi and psi are simple functions, so then c1 phi plus c2 psi can be written as summation over I, summation over j. So you will get c1 ai plus c2 bj into chi of ai intersection bj. So linear combination of simple functions will be again